Okay, so let's talk about how to find the domain of a function given its equation. So what matters is that only certain functions end up giving us problems with our domain. And so if we don't encounter one of those issues, our domain is all real numbers, which in interval notation is negative infinity comma positive infinity, which is this right here. And so if I'm looking at these problems in general, C shouldn't have an issue because I have an x squared and I have an absolute value, but there's nothing stopping me from putting in whatever values I want into those two places for x. So my domain there is all real numbers, or negative infinity to positive infinity. The problem with fractions is that if I get zero on the bottom somehow, then I have a problem because I can't divide by 0. So with fractions, what we do is we set the fraction equal to 0 and we solve. So in this case, I would subtract 5 from both sides and get x equals negative 5. So what happens is I'm allowed to plug in any number I want except for negative 5. And so if we're using interval notation to write that, we always start interval notation at negative infinity. We go to the number that we're excluding, we put a parentheses to say it's not equal to, and then this U is for union, which means we're saying both of these sets are part of what we're talking about. We put another parentheses with a 5 comma positive infinity. And so what we're doing is we're breaking this up into all of the values up to, I meant to put a negative here, up to negative 5, and all of the values past negative 5. That negative is really important there. So all the values up to negative 5, all the numbers past negative 5. Negative 5 is the only number excluded here. The other way to write this is using set notation with squiggly brackets, where we put x and then a line, and then we say x is not equal to negative 5. And all this is saying is that we're talking about x can be anything, is this first part. X can be anything, and then the second part says, well, no, x can't be negative 5. It's basically what we're saying. Part B, the top does not matter for domain, only the bottom matters. We set the bottom equal to 0 to figure out where does the bottom of this fraction give me a 0. And so we actually have to factor this to figure that out. So remember that if I factor this, I'm looking for numbers that multiply to get 12, that would add to get negative 7. So you can go through and list the numbers that multiply to get 12, 1 and 12, 2 and 6, 3 and 4. 3 and 4 are the numbers that add to get 7, and to get a negative 7, they would both need to be negative. Once we have this factored, we set each part equal to 0 and solve. And so that means there are two numbers for this problem that give us a 0 on the bottom. Positive 3 and positive 4. So in interval notation, that means that we are going from negative infinity to which number is farther left? Be 3. Then we can go from 3 to 4. And then we can go from 4 to infinity. And so what's happening is we're excluding 3 and we're excluding 4 by having those parentheses there. Then set notation, we'd put x and then a line and then say x does not equal 3 and x does not equal 4. Something like that. And that leaves us with D. Part D, we have a square root, and so we need to think about what values are an issue for square roots. Negatives are an issue. So whatever we have underneath our square root has to be greater than or equal to 0. Because I can take the square root of 0, and that's fine. So it has to be greater than or equal to 0 in order for it to work in our domain. So to solve this, I just have to subtract 2 from both sides. And when I do that, I get x is greater than or equal to -2. So that actually tells me my set notation. I would have x and then my line, and then x is greater than or equal to -2. For my interval notation, I don't start with -infinity. We're saying -2 is the farthest left number I can go to, and since we can be equal to it, we put a bracket. And we're saying any number to the right of that is okay. So we go all the way to the right to positive infinity.